All right, so before we go on to example 4, it's going to have us actually construct our own confidence interval. So there's this piece on your notes about constructing a confidence interval. So suppose that a simple random sample of size n is taken from a population, or the data are the results of a randomized experiment. A 1 minus alpha times 100% confidence interval for P is given by the following quantity. So basically, you can see from here, your point estimate minus, this is the formula for the margin of error, which I'll give to you separately in just a minute. But you'll notice right here, it's got Z and then sub alpha divided by 2. So what that is if you decide you're going to do a 95% confidence interval, then that means it's the 100% minus 95, which means I have 5% left over. So the 95 represents where I think my actual point estimate is going to lie. This 5% is what's left over. That is alpha. 5% is the leftover. And then I have to divide alpha by 2 because on my curve, let's say this is my point estimate right here in the middle. So that's my p hat. And then my margin, I'm saying 95%, there's a 95% possibility that it lies in here. That means the 5% is left over on these two tails. So I have to divide the 5% in half. 2.5% is going to be above and 2.5% is below. It would be the exact same thing if I, instead of doing a 95% confident interval, let's say I do a 90% confident interval. If I do 90%, then that means that 10% is left over, and that's my alpha. Alpha would be 10%. I divide that by 2. That means 5% is going to be left in one tail and 5% is going to be left in the other. So I've got an error on each side. That is what this is representing right here. This is your error calculated with using that alpha. All right, so with all that said, let me scroll down just a little bit. So there's your formula for margin of error. Again, I told you I would write it right there. So you can see you got p hat times 1 minus p hat, which would be q hat if you wanted to use q hat, to calculate the margin of error that you were using. All right, with all that said, constructing a confidence interval. In a parenting cell phone survey conducted by Princeton Survey Research Associations International, 800 randomly sampled 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving. Of the 800 teenagers surveyed, 272 indicated that they did text while driving. That number is probably really low. So this is going to be our p hat. So p hat is going to be 272 divided by 800. So let me get my calculator here. And so I can get a percentage. So 272 divided by 800 is 0.34. All right, so my p hat is 0.3. That means I can find my, let's see, we're doing a 95% confidence interval. All right, so with that said, I need to know the z-score for a 95% confidence interval. Well, that means if I'm doing 95%, that's 100 minus 95, which means I have 5% left over. But I have to split that 5% in half. So we're talking 2.5 above and 2.5 below. Now, the easiest way to find this, but I'm going to show you both ways because it's possible that they'll give you one that's not on your z-table. But if you will look on your z-table, the one that's downloadable from the notes or the notes page, or the first, I think it's actually on the home page. If you'll look, scroll down or look down at the bottom, you can see right down here, these are your critical values for your level of confidence. So that is exactly what you're looking for. So in this case, we're looking for a 95% level of confidence, and see right here, it's z sub alpha divided by 2. That value is 1.96. So that is the value that I am going to plug in to that formula. So, and that just comes straight off my, but you can see on your table, I have a 90%, 95%, 98%, and 99%. If they give you something crazy, which they might say 87%, then you would have to do it differently. Let's look at that. What does that look like? in this case, and I'll show you, the 95%, I told you just a second ago, so that's my 100% minus 95 gives me 5%. And I have to divide that in half because there's some at the one end and some at the other end. So that means 2.5% at each end. So now if I write 2.5%, 0.0025, I am looking for that in the middle of this z-table, which won't be on this page. It will be on, it'll be on the other page. So let's see, 0.0025. If I look for 0.0025, there it is. Oh, did not mean to do that. Actually, I'm wrong. It's 0.025. Ah, I don't know what I did. I don't know why this is all. This is frustrating. But 0.025, the closest I can is right here. So I don't know why it's not letting me write. Okay, there we go. 0.025. The closest I can get to 0.025 is right here. And if you look to the side, that's negative 1.96. So I have both the negative and the positive value, negative 1.96 and positive 1.96, which is exactly what down here on my level of confidence it says, 1.96. Both positive and negative because you have one on each end. All right, so with that said, let me go back to my page. All right, so now I know 1.96 is my z, so my z alpha 2 is plus and minus 1.96. So now I can use my margin of error, and I have 1.96 times 0.34 times 0.66 over 800. And then I'll have the same thing with the negative value. So let's use our calculator. And I'm going to plug that in, 1.96 times this is kind of hard to do on a keyboard. I know that y'all know that. So 0.4 times 0.6 over 800. And I get 0.03283. And you'll get negative 0.03283. Oh, let me go back to my page. Sorry, you're still looking at the calculator, aren't you? Sorry, I have to remember to switch back. Okay, so I get 0.03283 and negative 0.03283. So that's a 95% confidence interval. This is my margin of error. So I'm saying I'm going 3% or 3.3% to the right and 3.3% to the left. And so my confidence interval, and if you were writing the whole thing out, you would say, I can say with 95% confidence, point estimate lies between, and I'm going to do, let's just use 3% to make it easy. So I would do between 0.31 and 0.37. I just took this value and I added it and subtracted it from 0.34, and that's how I get my confidence interval.